Hi everybody. Today we're going to look at some negative number operations and see if we can get our head around it. So most number systems had numerals to denote positive numbers, and these are the natural numbers, so they're like from 1 to 2 squillion. The first recorded instance of a number like 0 was from Babylon in the 3rd century BC. So the whole number set, as opposed to the natural number set, includes the number 0. And although negative numbers were included by earlier cultures, Western usage is derived from the work of De Morgan and Peacock, and that was really late. That was only in the 19th century when they were formalizing the rules of arithmetic, and there's some nice pictures of them. So if we look, the idea isn't particularly amazing. Positive numbers are to the right of 0, and negative numbers are to the left of 0. So here I've represented 4 different numbers as vectors, as distances from 0. This is the vector of value of magnitude 4. This is a vector of magnitude 2. This is a vector of magnitude -2, so it's going in the opposite direction, but it has the same length. And this is a vector of -4. It has a length of 4, but it's going in the opposite direction to the vector of 4. So the number 2 we represent as this vector here. The number 4 would be this vector. If we added these 2 vectors together, we'd take the vector 4 and we'd add it to vector 2 on the end of it. We would have a resultant which would have a value of 6, because it is 6. The endpoint is 6 units from 0. This vector plus this vector is 6. Okay. Now what if we had subtraction? Well, we would take the original 4 take 2, we'd take the original vector of 4, and we'd change the direction of the positive 2 vector and make it go in the opposite direction. And then we'd take the resultant again from 0. So 4 take 2 is 2. So the answer is 2 units from 0. Okay, the interesting stuff happens when we subtract more than what we start with. So 2 minus 4, so we're using the -4 vector here. No, we're using the positive 4 vector in the opposite direction. And the distance from 0 now is -2. So 2 minus 4, this distance is 2 in the opposite direction, or -2. And similarly, if we use the -2 vector and then we add 4 to it, the answer is 2 from 0 to the end. So here to here and then here to here, -2 plus 4, the answer is 2. The answer is always measured from 0. Okay, and very much the case of understanding negative numbers, so you can see when you've made a mistake, is to relate it to a number line to start with, before learning any specific rules. The temptation to learn the rules tends to lead to errors in the long term, if you don't understand this first. And I get it. Number lines in primary school were a bit babyish and nobody liked them, but in high school they're actually really useful at times. So here we go. -2, subtract another 4. The distance is 6 in the opposite direction to positive, so the answer is going to be -6. -4 plus -2, so the -4 vector plus the -2 vector plus the -2 vector gives us -6. Now, the commutative property of addition indicates we could swap the -2 and the -4 vector and get the same result, so let's do that. We'll do -2 before we do -4. So here we did -4 first, now we're doing -2 first. -2 plus -4 is still -6. And this is counterintuitive, because when we think about minus, we think of subtraction and order is important. Well, we can change the order because we're adding. We're just adding negative numbers. So subtraction and minus, the sign, do different things, even though they can be used in an equivalent way, in a similar way, I should say. Now let's compare with the early case. -4 subtract 4. So we have a -2 vector and we have a 4 vector in the opposite direction. This is a 4 vector in the opposite direction, so that was this one. We changed its direction, we added it to the end. We got to -6 again. So here we can see that whether we subtract a vector or add a negative vector is actually the same thing. Here we added minus 4, which is this case here. Here we have subtracted 4, which is this case, adding minus 4, adding minus 4, subtracting 4. Okay, equivalence. Now, one thing to know here is whenever we've got a plus or a minus symbol together, we can simplify that to minus. And similarly, if we had a minus symbol, we could change it to being plus minus. And we use the concept of changing a minus to plus minus to simplify negative number arithmetic. So if we have minus 2 plus 4, we might change the order because it's addition is commutative. And then we have plus and minus together, we're going to change it to minus. And definitely it's easier to think about 4 minus 2 than it is minus 2 plus 4. We've done lots of practice with positive number addition and subtraction. We haven't done as much practice with negative number addition and subtraction. So swapping the order can make things a lot easier. The rules for subtraction of negative numbers are the same as addition. Change the direction of the vector. And if you're subtracting a number, it's the same as adding it, or simply minus minus becomes plus. So here we are going to subtract the minus 4 vector. So the minus 4 vector would normally go in this direction. Because we're subtracting it, it goes in the opposite direction. So we start here at 0, we go down 2, and this time we're going to go up 4, and the resultant will be 2. So minus 2 minus minus 4 is 2. Now this is horrendous to think about unless you start doing things that help you understand what's going on. We start with minus 2, we change the direction of minus 4, so in fact we're adding 4, and that gets us to 2. But just by looking at this and doing it by inspection is prone to error. You have been warned. Without some additional rules and some working. So let's have a look at minus 2 plus 4. So we have minus 2 plus 4 with the answers 2. If we swap these around, this becomes 4 plus minus 2 or 4 minus 2, which is just 2. Much simpler to evaluate the simplified expression than the original expression. Now, the way we do multiplication is quite simple. If we have 2 times 4, that's 2 lots of the 4 vector. Take the resultant, that's 8. 2 lots of the minus 2 vector, that will give us 4. Now, minus 2 lots of the 2 vector. In this case, we've done 2 lots of the minus 2 vector. Oh, hang on. So the 2 vector, change its direction, which is what we've done. And then we've got 2 lots of it. 1, 2. Yeah, that's fine. So change the direction of the 2 vector, it becomes minus 2, and then double it. Minus 3 times minus 2. Oh, here we go. Lots of minuses going on here. So we triple the minus 2 vector and then change the direction of it. Or we change the direction of the minus 2 vector first and then triple it and then, oh, what the hell? Yeah, this gets confusing when trying to think about it. We start with the minus 3 vector. Oh no, we start with the minus 2 vector to get to here. Then we change the direction of it, it's going this way. Which is this minus here, and then we multiply it by 3, and we get to here, which is 6. Another way of thinking about the 2 times 4 vector, 2 times 4 sum, is to double the length of the 4 vector. So that would be the 4 vector, double its length would be 8, the resultant is 8. Now this thinking is useful when we're looking at division. So in this case, we've got 4 divided by 2 equals 2, so that's saying halve the 4 vector. So here's the 4 vector, that's half of it, that's now the resultant. If we're dividing by a negative vector, again, change the direction of the vector. This is probably the hardest to visualize. So 4 divided by 2 is, we're dividing by negative 2. What have I said to do? 4 divided by 2 and then change its direction. So here it is here. So it would normally be 4. We've halved it. Oh, so first we've changed its direction then we've halved it. Once these problems get too complicated, the number line becomes less and less useful and we have to start working towards rules, but it's still good to always be able to visualize what it is you're trying to do. So here come the rules. If we have plus plus or minus minus, it simplifies to plus. If we have plus minus or minus plus, it simplifies to minus. If we're multiplying a positive number by a negative number or a negative number by a positive number, the answer will be negative. If we're dividing a positive number by a negative number or a negative number by a positive number, the answer will be negative. If we are multiplying two numbers with the same sign, the answer will always be positive. Don't know why I did that, but there we go. So if we're multiplying by the same sign, the answer is positive. If we are dividing by the same sign, did it here as well? The answer is going to be positive. Positive divided by positive is positive. Negative divided by negative is also positive. Now, here are some things. These are general rules that we use all the time. These are things that help us evaluate negative number operations, just make computation easier. If negative a plus b is also equal to b take a, the commutative property, we swap these over, plus minus comes together, it becomes minus. If we have a take b, we can simplify that to negative b take a. This can be handy when we're subtracting and b is larger than a. And negative b take b is equal to negative a plus b. This is handy when we're going to be adding up beyond 0. In fact, both of these cases are when we're going to cross 0 on the number line. Okay, so here's one of those cases, one of these 4, 5, 6, 7 cases. We've got negative 2 minus 6. We're not really sure whether this is going to cross 0 or not, so we're going to factorize out the negative 1, and that'll give us 2 plus 6. So rather than thinking, well, what happens here? Does it become larger, smaller, whatever? We can do a positive number operation, 8, and then multiply out the bracket, which gives us negative 8. I will try and demonstrate this later, but I'll introduce it here. So let's do some operations. 1 take 2 equals minus 1. 1 take 2 has a resultant of negative 1. Doing this with arithmetic, 1 take 2 equals negative 2 take 1. When this is bigger than this, you're better off just putting the negative sign out the front and changing the order, and that will get us to negative 1 as before. Negative 2 take 2. Negative 2 take another 2 will give us to negative 4. These are both negative. Take the negative sign outside and add them. Negative 4. Negative 4 divided by 2. Take the 4 vector, change its direction, and then halve it. Will give you negative 2. Negative 4 on 2 is the same as negative 4 on 2. 4 divided by 2 is simply 2. The answer becomes negative 2. So rather than having the negative attached to the 4, we've just stuck it out the front, because we know that the answer is going to be negative for this sum. So let's do some practice. Negative 2 plus 3 is going to be negative 2 plus 3, plus plus is plus. We'll change the sign, we'll change the order, put the 3 first and the negative 2 second, and then we realize we have to subtract, and the answer is going to be negative 1. Negative 5 plus plus 4, that becomes negative 5 plus 4. Now that we have a plus here, we can change the order, and that will become 4 take 5. The first number is smaller than the second, so it's worth taking the negative sign out the front and changing the order. So that becomes negative 5 take 4, which becomes negative 1. This may seem complicated at the beginning, but after a while it becomes very natural. 5 take negative 3, 2 negative signs together becomes plus. 5 plus 3 is simply 8. Negative 7 take negative 3, that becomes negative 7 plus 3, which is what I've done here. Taken the negative sign outside, so this also becomes negative. 7 take 3 is 4, the answer is going to be negative 4. This is a nifty trick. Negative 14 take 6. Two negatives, take the negative outside, then we can add the numerals together. 14 plus 6 is 20, the answer is negative 20. 6 plus minus 8, that becomes 6 take 8. This number is smaller than this one, it's worth taking the negative sign outside, and swapping the order becomes negative 2. 12 plus 7 becomes 12 plus 7 is just 19. Negative 8 take plus negative 1 becomes negative 8 take 1. They're both negative, take the negative sign outside, add them, becomes negative 9. Negative 9, take another 6, take the negative sign outside, add the numerals, we get negative 15. You can see here, once I'm comfortable with the arithmetic method, I don't have to worry about the number line, but I can definitely check it with the number line. I start with negative 9, I'm going to go down another 6. My answer is going to be lower than negative 9 on the number line. 11 plus minus 2, 11 take 2, which is just 9. Let's do some multiplication now. Negative 3 times negative 4, negative times negative is positive, 3 times 4 is 12. 24 divided by negative 6, the answer will be negative because it's positive divided by negative. 24 divided by 6 is simply 4, the answer will be minus 4. 5 times negative 18 is the same, the answer is going to be negative, and we'll multiply 5 by 18. If we were doing this without a calculator, 10 lots of 5 plus another 8 lots of 5 would be 18 lots of 5. Simply 10 lots of 5 is 50, 8 lots of 5 is 40 from our tables. Add those together will be 90, the answer is going to be negative 90. And if you do this by long multiplication, you'll probably find that this is still quicker. Well, maybe not in this case, but in most cases it will be. Negative 8 divided by negative 4, negative divided by negative is positive, 8 divided by 4 is 2. 17 times negative 4, take the negative outside, positive times negative is negative. 17 times 4, that's 10 times 4 plus 7 times 4, that's 40 plus 28, which will be 68. Don't forget to multiply the negative sign out the front. 8 divided by negative 9, so the answer is going to be negative. 81 divided by 9 is 9, the answer is going to be negative 9. 21, negative 21 divided by negative 7, negative divided by negative is positive, 27 divided by 7 is 3, the answer is going to be 3. Negative 7 divided by 9, negative times positive will be negative, 9 sevens are 63. 8 sevens are 56, no thinking required there. 57 divided by negative 14, positive divided by negative is negative, 56 divided by 14. Well, I might simplify that first. I don't know my 14 times tables. Divide them both by 2, that will give me 28 on 7. 7 goes into 28 4 times, the answer will be negative 4. Last set, doing a bit of everything, I think. 45 minus minus becomes plus, 45 plus 27. I might break this up to 40 plus 20 plus 5 plus 7, that's 60 plus 12. 60 plus 12 is 72. This is just done because I don't like thinking, and if I can do it simpler, I will. If I can write something down so that I don't have to do multiple operations in my head, I will. It's easier and less prone to error when you get good at it. 19 times 4, positive times negative is negative. 19 times 4, 10 times 4 plus 9 times 4, 40 plus 36 is negative 76. The brighter amongst you might have tried to do this with subtraction. Rather than having 19 lots of 4, you could say it's 20 lots of 4, take 1 lot of 4 with the minus out the front. That's 80 take 4, which will get you to the same minus 76 with one less step. Minus 45 divided by minus 6, minus divided by minus is positive. 42 divided by 6, 7 sixes are 42, the answer is 7. Minus 21 plus minus 19, plus minus becomes minus. Don't know why I've got plus there, let's fix that up. Oh, I know why, because I've done 2 steps at once. Bad me, I should fix that up. And you can skip steps after a while, but probably not whilst you're learning. Equals minus 21 minus 19, which equals minus 21 plus 19, which equals minus 40. As before, but with the extra step there for you. 30 positive divided by minus will be minus, 32 divided by 4 will be 8, the answer will be minus 8. 14 plus minus minus will be plus, plus minus will be minus, so you get 14 plus 7 minus 2, That's 21 minus 2, working from the left as per BIMDAS. 21 minus 2 is 19. This dot here is a very old-fashioned way of saying multiplication, more common in print texts, and back 30 years when I learned maths. Not so common now, but you might still see it, so here's an example of it. As you can see, the dot's in the middle rather than at the base like it is for a decimal point typically. Minus 8 times minus 4, minus becomes positive. And then divide the answer by minus 2. So you've got positive divided by negative, which will be negative. And it seems like I've lost the negative symbol when I've been doing this, so I better put it back. Minus, positive, negative, answer is going to be negative. So we end up with 8 fours are 32 divided by 2, which is minus 16. Negative divided by positive will be negative, and then subtract 17 from it. Be really careful about assuming that negative take negative will be positive. That's not the way it works. The simplification is only really done for multiplication and division. Negative divided by positive is negative. Take 17. 24 divided by 4, 6 fours are 24, and that will be negative. And then that will be positive. And then see, that will be 23. Well, let's check our answer. So that's going to be negative, so that'll be negative 6. That's going to be negative. Negative 6, take away another 17 will be lower on the number line. 17 plus 6 is 23. Yep, that's correct. So 7 plus 3 is 10. That's good. Plus negative 2 is going to be positives. 2 fours are 8. 10 plus 8 is in fact 18. Yuck. 12 plus minus 7, so that's going to be 12, take 7. Minus 28, that'll be plus 28. Doing this in steps, 12 minus 7 is 5. 5 plus 28 is in fact 33. So there you go. There's a good number of examples of how negative numbers work and how to use these sorts of rules and how to visualize it to make negative numbers easy. Well, with a bit of practice, I hope it is, and I look forward to seeing you in the next one. Thanks everyone. Bye.